Hello everyone. In this tutorial or in this session, I'm going to explain to you about the next part of the chapter 6, that it's actually about functions. In the previous part, if you remember, we have discussed about the defining the functions in the first place. What are the functions and what are the two types of the functions that are actually void, and the other one, which is the function that doesn't that actually returns a value. So these two types actually have been separated in terms of which type of function is returning a value. So whether a function is returning a value or not. The first part, as you know, it is void. It is called void, meaning that it doesn't return a value. It only executes a part of code, and whenever it's called, just only the part of code will be executed without returning any value. While the second one, it is actually regarding the int. I mean, like, it is regarding the function that returns a value. I believe actually in whatever, I mean, like, following the sequence of the slides in here, you are actually supposed to be studying or like be reviewing this kind of this type of function. I mean, like in the current part of the explanations. But I have actually I have intended to, I mean, like, to make it like this. It is because I cannot just only explain one type of the function while leaving the other one whenever we are actually talking about the two types of functions. So the second one here, which is the most important one, and I have also covered this in my previous recording, in the second part of the recording. It is actually about the type of function that has a return type that can be identifiable, meaning that it can be an int, double, char, or actually a string. So actually, this depends on the return type, if you remember that. So it can return whatever value it is, having that x has been defined here as to be whatever any value. Okay, so well, so this is the second part, and actually in this part of the session, I mean, like in this session, we will be discussing a lot about this type of function, because this is the most important. I mean, like, to say this is the most general one. I mean, like the void function, as you remember, I have also said this. Within the two types of the functions, void actually can be expressed as an exceptional or something like a special part within the function, because I mean, like, all the tasks and all the features that can be done within void, all the features that can be done within void, um, they can be actually handled by the other type of the function, and even more than that. That's why we call void, I mean, like, this type of function here, whatever code it is, this type of function, we call it as the, I mean, like, in my opinion, I'm calling it actually like a special type of function, while this one is actually the most dominant kind of function, the function that has a return type. All right, so coming to the point here, this is the first point that we're going to discuss. Well, it is about return statement here. So I believe that I have already explained this. I mean, I have explained a little bit about return when I was talking about the function that return a value here in my previous recording. So, but in this, I mean, like in this statement here, we meant something else. Here we are actually discussing the return statement in general. Something like we can use the return statement here in both, I mean, like in both the function that returns a value and the other type of function. However, I don't want you to mix with this. I don't want you to confuse with this, because I know now the first thing that will happen, I mean, like, that will come to your mind. I know that return, it's only used with the kind of function that only returns a value, but I cannot use it here. But the keyword, I mean, like, the return here in general description or in general explanation, to say it is actually to end the execution of the function. Okay, so whenever we use it with void, it can be used, but here we use it only to actually to end the execution of that function, and I mean, like, when we perform some code. So imagine that we have this kind of function, and we have some code here. Could be like defining variables, could be like a conditioning, or whatever kind of logic that can be inserted here. And then we had, I mean, like, we happen to put, or we happen to write return in this portion of function. And note that we still have some code to perform here. Can be another kind of code within the function. So this means that only this part of code will be executed. Whatever code that has been written before the return here, it will be executed. And note that we are actually writing return only without any value, because I want you to differentiate between this and this. All right, this one is actually to terminate. Okay, this one is also to terminate, but this actually is being used with the function that returns a value. That's why we have to append it, or we have to include x, or we have to include whatever value. I mean, like either a value or a variable name or actually an expression. I will discuss this with you actually in more details even. However, I have done this in the previous recording. Okay, so here in this slide, when we talk about return, we mean to, I mean, like we meant to that, I mean, we are implying to that keyword that actually indicate the end of the execution of the function. So it can be placed anywhere in the function. Statements that follow the return, statements that follow the return statement will not be executed, as I have mentioned in here, as I have mentioned to you in a previous in the previous snapshot here. So what I want to say is that, so this kind of code, whatever code it is, I do not want to go in further details, but I'm just showing the general purpose, or like the general shape and the figure of the return. So whatever code here, it will not be executed once we have inserted return. So how can we use that? This is actually, I mean, like in which cases this can be used, the return. And I want you to know this. So we cannot, again, I'm saying, since I'm actually now comparing here, I cannot actually put return, I mean, like in this way in the int function, or like in the function that actually returns a value. It has to be with a value. It must actually to be with a value. But here when we talk about void, of course, because we are not returning a value, and also the I mean, like the purpose of it, it's actually to end the execution of the function in a specific point. So that's why we use it like this. So we can use it to prevent abnormal termination, and I will show you now an example. What do we mean by abnormal termination here? So there is no error actually if it is not placed, meaning that if I just remove this, I will not have any kind of error. Okay, even with this one, if I remove it, I will not have any kind of error. But of course, when we talk about like the function that returns a value, we are expecting a value to be returned. But I'm talking, let me talk now about the return in the void statement in particular here. So when I remove it, it should not actually affect the I mean, like the code, meaning that a compiler will not bring me any kind of error. Well, so this example actually explains what do I mean by abnormal. What do I mean by abnormal termination of the program? Well, so let me just have this in my compiler. I'm just moving you to that compiler, to the compiler in here. This is the closed one. All right, so this is a very clean copy of the compiler. Well, so I'm typing now. I want to actually add two numbers. I want the user to identify two numbers, to enter two numbers, and I want to divide these two numbers. Having that, if the number, I want to make a condition in the second, in actually a function, that if actually the number is, if the second number that a user enter, which is dividing number 1 by number 2, if the second number that the user enter is actually more than, it is 0, then I will just return and exit, use the return keyword to exit the I mean, like the division, because I cannot actually divide any number by 0. This is actually the main purpose of using the return. So it is to avoid dividing any number by 0. Okay, so how to write that? It is actually by, first thing is that I want here in the main, this is just an example. You can just refer to this one if, I mean, like to get the idea. I will be typing typically the same example as in here, but because I want to show it to you in action, that's why I'm typing it. So I'll be defining number one and number 2. And then I will ask the user to read them, enter the value of num1 and num2, where num1 and num2 to divide num1 over num2. Okay, well, so now the user is already knowing that he already knows that what actually kind of number can be in the first, in the numerator, and which number to be in the denominator. So this is the upper part, and this is the lower part. and then I'll be using the cin here to read the two numbers, num1 as you know, num2, and then that's it. So here, of course, I should be calling another function. That is actually the function that will perform the return. Okay, so I will not actually call the function now. I will just go simply, and because I'm just giving you the best practice to, like to build the function. You don't need to create, like you are not advised to make the call first, because as I have discussed, as I have advised you before, it is actually better to go and create the function and then identify its prototype in here, and then finally go with the call, because the call here happened to be the last step in creating the new functions other than the main function. So my function here is void. Void, I will call it just divide, and that function, of course, it needs to take these two parameters. If you remember from the last lesson, we know how to pass these two parameters. So we are here passing, like this function is to receive two values. So these values are to be stored in two parameters. Of course, the parameters has to be of double x, for example, and double y. Okay, so open and close brackets in here. Of course, because it's void, then I don't need to write any kind of returning value. Okay, but I will be using return now to terminate this function in the middle of its body. Okay, so my code here, it will be as simple as an if statement, as you are reading in the slide. Okay, that actually is saying that if y here happened to be the second number. See, because here I'm actually calling the, well, let me just before I go into the body, let me just make the call so that I can give you the clear picture about what's going on. I will go first and define the prototype. The prototype, as you see, as you remember in the last part, in the last class, it is to copy paste the function header with a semicolon. This is the easiest way to memorize it. Well, so, and again here, because I'm calling this function, I want this function to be executed, so I will need to again call the function in this way, but of course there is no there's no data types in here, so that will be actually number 1, that will be here, and then here will be number 2 to keep reading, like the function, and don't forget the semicolon here. All right, so this is it. So now number 1 will be received in x, and number 2 will be received in y, and here my condition is actually to guarantee that, make a condition that if y is equal to 0, then, of course, because this is double, so I need to make it in a floating point way. All right, so I have my condition in here. My condition will be as a cout, sorry, I can't divide, for example, I can't divide by 0, whatever message actually. So and this is it. So let's just make this as a new line. Okay, and here this is my return. Okay, so here what it does is that actually it terminates the function up to this point, no matter even if I have another code here that actually says that displays the normal, like if in case this y was not 0, it will display a normal division. So the division of x over y is, for example, and let me just type this and saying, let me just add the operation right away in the cout statement and say x divided by y. I can do that actually, and then end line. So, well, now this code is ready for execution, and let's just start and see what is it. So here, number 1, because now I want to reach to the situation where the second number happened to be 0. So first number you can put whatever number you want. Second number, let me just put 0 here, and then here, sorry, I cannot divide by 0. And then if you notice here, I didn't have this message displayed. I didn't have this kind of message displayed. It's because that the compiler here, whenever it notices that there is a return here, it actually terminates the whole function and then returns to the I mean like returns to the main body, to the main function. And if I have in the main function, let me just add this and add whatever code in order to show you that the compiler has already even returned to the main function and executed whatever code in the main function after that. So again, if you compile in here, so put whatever values and make sure that the second one is 0. So here you can see, so it executes that message, and then it actually skipped whatever code, which is this message, and then actually after it terminates in here, it turns back to, I mean like the compiler turns back to the main statement, or to the main function, and execute this, I mean like as a message, as whatever code in here. Okay, so now you can see that how, I mean like you can see the importance, or like you can see the impact of having return in here. Okay, so if you remove return here, let me just also go with you, since actually this is like has been brought into practical. If you removed return in here and just put whatever number and make sure the second one is 0, so you can see here division of number x by y is inf, which is infinite. So meaning that it actually, the whole code has been executed, because there is nothing here that imposes or that actually influenced that function to terminate. That's why you can see here whole of the cout statements have been actually executed. All right, so the return statement here can be used with actually both functions. Can be used with the both function types as a return. So the return here acts as a break. If you remember in looping, it actually, we have used one keyword called break. Actually, we cannot use break here to, I mean like to answer some of your questions. If you're wondering, we cannot use here break instead of return, because actually break is only being used when, you know, like when we have a loop. Okay, so with the value returning function, which is the int or double type, I mean like the function that has an int or double other than void. Okay, so it must be followed with a value, or I mean like that can be return x, return y, return x plus y, return maybe 1 2 3, kind of literal. Or like when we talk about like void functions, and this is the one that we are actually explaining here, so it has to be only mentioned as it is. So you can see, so it has to be mentioned alone without any value. Well, so returning a value from a function. So now we are actually talking about this kind of, function here. These kind of functions it can be actually int, so it can be int, double, can be char, also bool, and I have already forgotten that, and I will be talking about this actually in a very unique slides in this part, and also can be string. Okay, so all of these are actually the the return types that we can use in this place. So again, I have already explained this in the last part, and here even I'm giving it enough time also to, to emphasize on it again, only just walking with the slides in here. So return here, it's returning a value from a function to the model where the function is being called. What do we mean by this? So imagine that we have this actually call, and here we have main, int main, which is the function, the main function, and you know already that the main function is the first function to be executed, and this is the point of call, calling some function. Okay, so here we call this as a point of call, so the call is sum. Okay, so here, so when we call this function, it is actually returning the value of x only. I mean looks like this function, it's like something like a variable that it actually has only one value. So meaning that actually you can, like whenever you see out it, as you remember in the last part that I have explained, if you see out this kind of code, it will give you 8 only, or whatever x is, even if you have another variable here, but you cannot actually excuse me, like return more than one variable in here. Okay, so it actually returns, so the value of this function is the value of the return. Okay, so up to this point, this is what we mean by this. Okay, so prototype and definition must indicate the type of the return. Again, so what do we mean by that? We mean that actually whenever you are typing the the prototype in here, prototype, okay, so you should actually indicate whatever the type of the function and the function name and also its parameter list with that one, because the parameter list here is empty, so we do not have any parameter list. All right, so calling a function should be used, calling a function, it should be used, should use the return value, for example, as like this. So this is the way how can we manipulate the return. I mean, like when we call the function, like imagine that you're in the main and you're calling this kind of function that actually returns a value. And so you can use it as here, which is this one is actually number 2, or you can actually assign it to a value, a variable. Like let me just say this is like set. I just want to copy the exact function name here to go with the same like the same example. Okay, so set. So here I can actually add it into a variable here, meaning that I can define a variable here in the main function where I'm calling this function. I mean, like when I want to call this function, I want to use it. So in, for example, x, and I can put it equal to set like this. So here, meaning that I'm copying the value of this function into a newly declared variable that is x. So later on, actually, I can like see out x here, or instead of sum, or I can like maybe even make a sum. I mean, like make some kind of operations, and this is actually the other one that it's actually happening to be in here. So I can actually use it in an arithmetic operation. All right. So the call of that kind of function, the int or the double, whatever function that has a data type, a returning type, it is actually very flexible, and I can use it in more than one fashion, as you can see in here. And I can also, I do not want to forget this, I can also actually put it inside I mean like a comparison, because finally this returns a value. This returns a value. It's, you can like imagine it, you can imagine this function as to be like here 8. So whatever, if we compare like x less than set, I mean like the set function here, so meaning that we are actually comparing x to be less than 8 in this example, as you can see here, because we are returning x. So whenever we are using it, so meaning that we are actually comparing the, I mean like x to the value of that function. All right, so the format, so it is just a return and an expression. So this is how we use it. So expression may be a variable or literal, or can be an or can be an expression. I'm talking about this one, the expression of the return. So it can be a variable, or it can be actually number, or like maybe I just want to return any literal. Okay, but the important thing here I want you to know from now, okay, without even going into the, I mean like following the slides, but it's mentioned, actually it's already mentioned within the slides, but because you see the information here and the points here that whenever you are actually being explaining the, I mean like the function, is that you need to bring everything in the same point, because this will actually because actually both, I mean like all of the functions are really connected together. So now we are talking about like the return, what kind of value to be returned. So we are returning, for example, 8. Why 8? Can I return 7.8, for example? No, I cannot. Why? It's because this has to be following exactly the same kind of return. So I want you to remember this. So this is the return type. It has to be typically the same as the returning a value. So if it is a literal, so it has to be integer. So if it is a variable, so this variable has to be declared as an integer, typically same as the returning type. I hope this is actually very clear. I have already explained this in the last video, and I'm just emphasizing on it now. All right, so expression should be for the same data type. This is what I'm actually explaining just now. I'm telling you that the data type of the return, which is like, for example, x here, it has to be typically the same as the returning type. So both of these must be the same. All right, so imagine if I have like another variable called double x, oh, let me just use t, for example, 4.3, and have a char f equal code, let me just say it, code equal to r, for example. Okay, so if I ask you, and I have this actually to be double, which one among these three parameters, or these three variables that I can use as a valid return here? Of course, that should be the double. Why? It's because I'm having the function return type here as double. Okay, so how I return this? So it's just only by calling variable name. I can use this, but of course it's not logical. You see, you're actually defining a variable and assigning it a value. It's not because you want to use the value itself. So this is actually, I mean, like if you type 4.3 here, it is actually not reasonable. It is just, something like you're just using a variable, or like you are actually allocating a memory in a memory one variable for nothing. Okay, so it's much wiser for us. It's much wise for us to use t whenever we are actually whenever you are going to read values. So here we are using t. However, signing a variables itself, I mean, like in general, I'm talking, even this kind of function can accept whatever value. But of course, this is finally depends on the code itself. It depends on the kind of question, what it asks. But I'm telling you the techniques here. What can make the code correct? What can make the code have a syntax error? If you choose to, to return X here, whenever you are compiling this code, it will give you an error. Why? It is because it tells you that the double here, it is not same as the data type of the return value, which is int here. Okay. All right. So it's something like this exactly. So it has to be both, has to be the same. All right. So look at this part. Look at this example here. So we will have over here we have a program that actually calculates the different calls of the call sum of the function, passing a variable, passing the content of a value 1 and value 2 into an argument, and then assign them to the total variable. All right, so this is the one here. So we can just return. This is how to use the return in a kind of an integer, a function of a data type of integer. It's actually a pretty easy, and you can just we can just simply convert it into this code. Let me just go ahead and type it with you. I really advise you to go and practice a lot and a lot. So whenever you're actually reading these slides, even though if you are actually whenever you're actually viewing this video, even if you're just listening to the video, I really recommend you to go and have like any kind of compiler in front of you, either to be a web-based compiler like Shell C++, or actually kind of standalone compiler like this one, CodeBlock or Visual Studio. But I want you to actually practice this as long as you are actually reading, listening to the video. All right, so the example here, it is to define two values, val1, for example, equal to, I just want to make it so easy, I do not want to complicate it. All right, and val2, that will equal to, let me just put it as 11. Okay, and also I want here to okay, so I want actually to pass these two variables into a function that actually called sum. It will actually compute the sum. Simply, it's just a simple value to imitate this kind of code here. All right, so as you can see here, so the total here, so it is another variable that actually sum can be stored in. So let's just create that variable, int total. Okay, and that will equal to directly sum. It will equal to this directly. So sum, and of course sum have to send those two values in order to calculate their summation. And whereas where I'm calculating summation, it should be calculated in another function that should have the return type here is int, and the function name is sum, and it's receiving two values x and y. Int y, you cannot actually type xy like this. I want you to remember this. This is very wrong. You have to initialize, or you have to identify each parameter in a different way. All right, so this function can just only return x plus y, as simple as this. You can do that because if you remember in the last slide, we were talking about the different conditions. How can we use the return? How can we use the values of the return? Okay, so of course, I want to also to create the prototype here. So I'll just simply copy paste this, and I have forgotten don't forget this, because this is the prototype. Prototype has to include the function name, the return type of the function. All right, so this is how it is performing. Oh yeah, because I didn't actually, yeah, it's because there is no C out. It is just I'm returning this value to be stored in the total without any C out. So the C out here will come as total of summation is, that should be total, end line. Alright, so let me just execute this and you can see. So total of summation is already 20 here. So it looks like that these two variables have been sent to a function in order to calculate the summation, and then the function, I mean like that value has been returned and stored in another variable, in a variable called total, and then I have displayed total. I can display this also. I want you to remember this. I'm trying to answer as much as possible of the questions that may come into your mind. That's why, excuse me if I'm just taking this video too long for you. But you see, because like some students are really kind of curious to know more about the I mean, like about the other kind of changes in the code that might happen. So if we executed this part of code, I mean, like if we executed this code, of course it will have the same answer, because you see, whether you are returning, you're using the function itself, or you're actually assigning its value to another variable and call the variable here. Both ways you are getting the same results here. All right, so let's just come and forward here. So this is actually how it goes on. So the return type here. So in sum, this is actually explanation of what has gone in here. Okay. So I have just typed it in the I mean like in the different way. If you see here, so I have just already, I mean like I have just typed the, I mean like both parameters directly into the return, but you also can actually create it in another variable and actually call this as, for example, z equal to x plus y. You can do that actually also, and you can here call z. It's very possible, and I think this is even very intuitive, meaning that it should come into your mind directly without, you know, without the need to think of it. Okay, this is how the, I mean like this kind of example is returning. So this is the values being returned, and I can use it. This is the return type, and remember, so it has to be of the same data type of the return type. Okay, so all right, so the other point here, coming to the other point, that it's actually the return type, or like the Boolean return type here. Okay, so function that returns either true or false. So it is simply as, I mean like if we are, I mean like it is as simple as if we talk about bool. You remember that we have a, I mean like a bool, it is a data type that we can actually assign it to a variable to be, for example, any name, a, or bool, for example, test equal to 1, or can take either 1, or it can also take, I mean, let me just put it here, or 0. So 1 is for true, 0 or false, I mean like it is to indicate false. Okay, so this is the bool in order to use it in a variables to say. But we can use it actually in as a function return type. It is like by typing the same, for example, whatever name of the function, this is finally up to you to write the return, I mean like to decide the function name. But here, return true. What does it mean? If I call this here, if I call this in like cout statement here, saying test, for example, just ignore this. Okay, so if I call this here, it will return me whatever true value is. So what is the value of true here? As you know from previous experience, it is 1. So this kind of code will actually it will cause that print out to, I mean like to print me number 1. If I call it to be false, it will actually print 0 to me. And this is actually what we mean by, in general, actually I'm just summarizing you whatever the theoretical points here, how they are being summarized into the code. It is just like this. Okay, so let's just read ahead here. So it either returns true or false. It doesn't return the letters, while it returns the value of the letter here, the value of that true value, meaning that either 1 here or 0 here. Okay, so it declares the return type in the function prototype and a heading as bool here. I think you already know. You already I mean like it is just trivial to know about this. So whenever you're actually declaring that, I mean like having a function named bool. So in the prototype here, proto, in the prototype you have to have it as bool, for example, test, and the parameter and the parameter list if you have parameters you are receiving. Okay, so this is what we mean by this in here. And also in the heading, where is the heading here? This is the heading. So this is that prototype. We have to include the return type, and this is the heading. The heading is this one, which is the title of the function. Okay, so this is the heading. So of course it has to be included here. All right, so the function body must return either, I mean like the statement that returns the true or false. So it can return the true or false itself, as if you remember in the int, the function that returns an int. So if I'm typing here int val, for example, I just want you to I mean like to see the difference. That's why I'm bringing this example again here. So int x equal to 8 and return x. Okay, so here I can say bool, for example, bool s equal to true or like false, and then I can return s. Because finally this is just a value. False or true is a value, and 8, 10, 11, 12, it's a value that has a data type of integer. That's why we can do the same thing as we have mentioned into the int function. I mean like the function that returns an integer type or double type, meaning that you can either write here true or false instead of s, which is the variable name, or you can use a variable name, but you need to make sure that the variable has been declared as the same data type of the function returning type. And of course this has to be declared in the prototype. All right, so this is how, I mean like this is what do we mean by the points in here. All right, so I do not want you to go, I mean like I'm not going to imitate this in the compiler, to transfer this into compiler. You can just try this by your own, because the idea here is very clear, and it's kind of redundant. If I want to, I mean like redo it, it's exactly the same idea as this example in here, but let me just go through with you here. I mean like roughly is that this is actually to indicate that whether a number is actually lies within the range or not. So how is that? It is like here in the main function we are actually identifying, I mean like initializing a variable, and it holds the number 9, for example, and we want to check whether number 9 here lies between 0 or 100. How we check it is that we send it as as an argument. Remember, this is an argument here, and we receive it in a parameter in another function. So we are already out of the main function here. So this is the bounds of the main function. So we are sending it as an argument and received into a parameter here, that its number, and then here inside that function. So we want to we identify one variable, as I told you just now. Remember this example. So we can either define it like this, and then we can now compare. So we define now the variable here. So now this function is receiving an integer and handling I mean like defining a boolean variable here. So the condition here, in order to decide whether this number, because this is the main purpose of the question, to decide whether this number lies between a range or not, and this is the range that we are defining. So that's why here we put our if condition. If number, which is that one that we are receiving, and it should be the same variable name, okay, if that number is greater than or equal 1 and less than or equal 100, this is actually the way how we identify that a value lies between the range, within the range. Okay, not or, it has to be and. Remember this from chapter 3, I think. All right, so as a response, or like as a body of the first part of the condition here, then we update that variable status that we have created here to be true, and then else we update it to be false. There is actually another time, I mean like finally here, we are returning the status. So whatever the status type is, we are returning this. Actually, this is one way to write that example. And to be honest, actually, this kind of example, in order to write it like this style, it considered kind of consuming to, I mean, like consuming to the memory. So another way of writing it, it is much better to include the return within the body. Why? It's because the compiler doesn't need to go to both if and else part, okay? Or like check whatever, especially if you have a code, especially like here, especially here, if you have a code after the else. Imagine that, assume that you have a code after the else part, meaning that whatever kind of code before, I mean like between the, I mean like after the else and before the return. So this will actually this will make the compiler need to go through the code and actually execute it. But if you don't care about like whatever code it is there, so you can just make the return from here, because this function is already, I mean like it's only has been made for the purpose of checking only. It doesn't actually compile any kind of code. So that's why you can write it like this to return true or return false. This is actually typically the same way as this. It's both of them are actually same here. It's only the way how we write the return. Of course, this is more clearer to you. This one seems like more structured. You're defining a variable and then you are updating the variable to its value, whether to be true or not. Okay, so you can, by the way, you can use either ways actually in this. All right, so for that, now we have already learned about the different types of functions, and you can actually use the function to identify. You can actually use a function, I mean, like by both of its types, either a returning value function or a function that doesn't return a value within the program. Actually, if you refer to the textbook here, let me just okay, if you refer to the textbook here and to that example, let me just go and check that out. Yeah, so it should be 614. I'm just referring you to the example where I'm going to handle 614. Yeah, this is the one. Yes, this is the one here. All right. It is actually a very long example, kind of a long example, but it's very meaningful, and it has a lot of like a lot of ideas where you can like create a function to be, I mean like very create a function that can, I mean like use an implementation of a function that can be very creative and very helpful in a real world scenario. Okay, for example, this one, I mean like this kind of program, it is actually to make I mean like a user selection. This is how, I mean, like the output will come out like this. So you have a list and you'll be selecting. So like to identify, I mean like to identify the membership. So health club membership menu, you can check, and I mean like you can select your, I mean like the options between these options. So if you entered one, then you'll be asked, I mean like this question, I mean like kind of an information, and then in order to calculate the total charges. All right, so how it is actually going, how it is functioning, I will just go roughly with you. I will not explain it thoroughly because I will leave this to you. And I really hope that if you have any question, you need to, I mean, like to consult back with me, because this is the part where you need to implement. I have already explained you the basics and like the, I mean, like the important and the general information about like the functions and the both types of functions. Now it's your turn to understand how these functions are working when they have been implemented. So the main purpose of this example, it is to show you how function can be part of the menu driven program. So this is the kind of a menu driven program you can see here. So we have a switch example here. Doesn't matter how the switch, I mean like what the switch is actually doing, but here within the switch we have different cases, and these cases actually they are executing in each case that function is executed. So here, instead of having a code, so whatever code here, it will be executed from this function. So when the compiler reaches here, show fees, so it will go to the function that has like the function of show fees, which is here, that it's written here, and then executes this code. So this will actually save a lot of time and a lot of space in the, I mean like in the code, especially if you want to repeat this kind of function again and again here. See, because we are repeating it more than once. So that's why using function here will bring an advantage of arranging the code and minimizing the amount of code that we need to write. So instead of keep typing typically the same lines in each case, so we can actually shortcut them and just I mean like append them or like include them in one container or like one block of code that is called a function, and we just use the function in order to call it. Okay. All right. So I want to bring your I want to bring your attention. Excuse me if I'm jumping a lot between the different ideas, but it just come to my mind from this example, and I believe that I have already explained this in the last chapter. But since we are already in the same point, let me just go with you and explain how can we read and what is this? How can we actually transfer or like send a string variable? So this is kind of a string value. Okay, so you must put it within two double quotation. Okay, this is a variable name, this is a variable name, and this is a value that actually belongs to a string. So please remember this and try to differentiate between the different items that are being inserted as as arguments here. Okay, so let me just go with you, and I will just give you a simple example of this. So imagine that I want this to be as a string to print your name. No, to ask you to enter the name, or like to print the name. So my name here, or like show name. So that will actually have a string name, and here it's only about CL. No, it's only about returning the name. So before I return the name, I have actually to okay, so let me just, because I'm thinking of the logic now. Right, so finally I'm going to return it is just, oh yeah, so we can actually just change this to be void. Doesn't matter to be to be a returning type. We do not need to return here. It's just rather we need to see out here. But because like my idea here, when I saw this, I want you to know how can we transfer this as as a text. So here my point is that okay, you can either have a string, like a variable called val1, and that should be, for example, Ali, and we do not need this we do not need this code. And then here I will just simply call the function void, call the function show name, that it's actually having either val1. Okay, and here that should be written instead of as a prototype here. Okay, so this is the code that I'm trying to execute with you. Forgotten that almost necessary mark. Okay, so so yeah, see out, that should be my name is name, end line. All right, so and then I'm just okay, so yeah. All right, so how we use that? So it's just like this. So we are not returning a value here, so it's just example. Yeah, that should be not val1 actually. So see, this is the point here. If you have typed this, since you are actually talking about strings, if you have, this is actually error. So this is logical error to say. This is kind of a logical error. Okay, why? It is because you cannot actually, I mean, like whenever you want a function to type your name or to show your name, this is not your name. This is the name of the variable that holds the name. Okay, so that's why in the call, this is my point here. It's that either you it is that either you use the variable name. So here we have used call, or like we have sent uh, data by variable name, or in like show name we have sent a data by Ahmed by actually the value, sent data by value. So these are two different, I mean, like, of course, these should be two different, and you should differentiate between these. So this is a value or literal, and this is actually a variable name. So this is actually what I want to show you here. So having this between the double quotation, it has to indicate that this is actually a value, not a variable name. I mean, like, other than these two items here, where actually both of them are actually variables, as you can, if you have just, I mean, like, review back into the question. Well, so you can just review that program, and if you have a question, as I told you, you can just come back and ask me. Well, so now this is actually another point, and it's a totally different point. So let me just pause this video before I start here, and even like try to give you some rest in order to start you with part 2 of this session. So I will show you I will be seeing you in the other part to continue in this session. And for that, thank you and see you again.